Guys, what's up? So today we are going to be proving that x squared minus y squared is equal to x plus y times x minus y. Now, what is x squared minus y squared? Well, it's a normal identity which you might have studied in standard 8. And well, you already know that this is equal to this quantity x plus y times x minus y. Now, there must be a proof behind it that how we got to know that x squared minus y squared equal to x plus y times x minus y. So today I'm going to be proving how this is going to be equal to this, and there are going to be two alternative methods by which we're going to prove this. So let's prove it then, shan't we? Okay. So this is a square. Okay, consider a square with side length of x. Right, so obviously the area of the square is going to be x square, right? Now let's make another square, and imagine you are making another square, right? With side length, with side length of y, and now you are just subtracting the area of this small square by the area of the bigger square, right? And now please see this very carefully, which I'm going to do. Now for you to get, now what is going to be, now for you to get the x squared minus y squared, you need to get the area of this region, which is not cutted, right? Let me just get this. So what is the area of the big square? So it's going to be just x squared, right? And now a little square has been subtracted from it, which has a side length of y. So what's going to be the this area of the small square? It's going to be y square. So what we're going to do is we're going to subtract this area, right? Now you need to get, if you want to get this x square minus y square, you need to calculate the remaining area, this area I'm talking about, right? This remaining area. So how are we gonna calculate this? Now I don't really have a specific formula to calculate the area of this irregular shape. So what we're gonna do is we're gonna divide this shape into two different parts, right? So I'm just gonna quickly find a tool which I can do this. Wait a sec. Right. Okay, so we are gonna divide this like this, right? Right. Now let's label this upper area as area 1, and this lower area as area 2. And we definitely know that x square minus y square is going to be equal to area of 1 plus area 2. Right? This is going to be equal to area 1 plus area 2. But the question is going to be, how are we going to calculate area 1 and area 2? And well, it's pretty easy. Okay, let's go. Oh, I'm sorry about that. Area 2. So how are we going to calculate area 2 indeed? And first of all, let's just calculate area 1. So if you look at it carefully, area 1 seems like a rectangle. And what's the area of rectangle? It's length times breadth. And what is the length? In reality, the length is just x, right? We are talking about this region. So this is equal to x. So this is going to be equal to x. And now what about this length? And it's actually even easier. Now you know that this whole length is equal to x. And this small length is equal to y. This small length is equal to y. So what this is going to be? Don't know. Well, consider you have a shape like this. You have a line. You know that this whole line is equal to, let's say, 5, and this small part of the line is equal to 2. So what is this line equal to? You get it? It's 5 minus 2, right? So that means this small line is equal to x minus y. That means we came to the conclusion that area 1 is equal to, first of all, x times, I'm just going to put that in bracket, this length, right, which we calculated to be x minus y. Interesting. This was the first area. Now let's look at the second area, which is going to be the area number 2. Right? Let's just remember this. Now let's get the value of area number 2. Now area number 2 also seems like a rectangle. So first of all, what is the length of the rectangle? I'm talking about the breadth. Right? Isn't the breadth just y? This we are talking about. Because this was y, so this is obviously going to be y. So it's going to be y times. Let's just write this like this. And 2 is equal to y times. And now it's the same concept. If this whole line I'm talking about is equal to x, it's written, and the small part is equal to y. Obviously, it's a square, so all the sides are equal, right? All the sides are equal. This is equal to y. Then this portion is equal to x minus y. Simple. Now we know both the things. And now it's just a simple step. We have to add both the things. So finally we came to the conclusion. So our first was, okay, let's just write this. Right. So our first was x minus y. And then it was y, x minus y. And this should be equal to x squared minus y squared. Should be equal to x squared minus y squared. And actually, now you can even solve this if you know factorization. Okay, so this should be equal to x squared minus y squared. Now you can see that there are two equal terms, or there are two equal factors. So now you can take out common x minus y. You can take common. So what's left on this side? Well, x. And what's left on this side? Y. And don't forget the sign. Boom. We literally just proved this. This should equal to x squared minus y squared. I didn't have space, so I write it like this. So just